Okay, this is the next problem. This is problem 20. This one, it asks you to do it without a calculator. It asks you to enter in X, Y, and Z into these expressions without a calculator. And I would definitely try it without a calculator. Now, I can't hold you accountable. I mean, I won't know if you used a calculator or not. But I can tell you that, the SAT has a no calculator portion, which probably doesn't pertain to you. But many colleges require no calculators, like, especially your freshman year. Some placement tests, will not let you use a calculator. I mean, there's situations where you're going to be without a calculator in algebra, and hopefully you can get this practice in so you can do this without a calculator. So x cubed was 2 cubed, which is 8. So I'm just going to enter in 8 right here, times y, which is -4, put that in parentheses, divided by 2 times z, which is -3, and that's all going to be squared. So let's see. I always reduce when I can. First of all, these double negatives cancel, so I can make those positive. 2 goes into 8 4 times. 4 times 4 is 16. So you have 16 in the numerator and 3 in the denominator. And then I need to square that. Okay. Let's say you don't know what 16 squared is. Well, what you can do is just do your multiplication method that you learned in elementary school. 6 times 6 is 6. Carry up the 3. 6 times 1 is 6, plus 3 is 9. And then follow through with the 1. 1 times 6 is 6. 1 times 1 is 1. So you get 256. So just enter it in as a fraction, 256 over 9. And we'll do the next one then. The next one, x is 2 plus y is -4. All over x is 2 minus z is -3. Double negatives go positive. So and we're going to raise this to the x power, which is the second power. All right, so this simplifies to -2 over 5 squared, which is just 4 over 25. If you square the numerator and the denominator. So just enter in 4 over 25 there. I'm going to go back and do a couple more of these. I think this is 18 real quick. This is 1 to 3, so you're going to enter that in interval notation, so it'll be 1, 3, and then use the brackets on your keyboard. Not the parentheses, but the brackets. This one says simplify the expression, give your answer in the form of like a function over another function. So we need to get this to look something like this. All right. Anytime you want to add fractions, you need a common denominator. So I'm going to basically multiply the top and the bottom of this by this denominator, x plus 2, top and bottom. And the same thing with this. This needs to get multiplied top of that 2 and the bottom of the 2 by x plus 2. So I have x times x plus 2. Oops, x times x plus 2 all over x plus 2 plus 2 times x plus 2 all over x plus 2 plus 1 over x plus 2. So now I have a common denominator, and I can just go ahead and add the numerators and put it over that one denominator. So it's x times x plus 2 plus 2 times x plus 2 plus 1 all over the common denominator, x plus 2. So obviously the bottom function, we're just going to enter in x plus 2. That's going to be the bottom. The top, this right here. It might accept it if you enter it in like this, but we should simplify it probably. If you do that, you'll get x squared plus 2x plus 2x plus 4 plus 1, which simplifies to x squared plus 4x plus 5. So I'm going to try entering that in. Yeah, that works. Okay. Next problem wants you to match these intervals with the inequalities. So it's saying x is defined, from 5 to 8. So this is from 5 to 8, including 8, but not including 5. So I'll just start here and work my way this way. Not including 5, but including 8 would be 1. So this is A. This means all the numbers less than 5. So all the numbers less than 5, not including 5, would be 4. So this is B. C, this is all the numbers bigger than 5. So it's 5 to infinity. So there's C. This is between 5 and 8, not including 5 or 8. So that'd be this one. D. And then obviously the last one's E. It's from 5 to 8, including both 5 and 8. So if you're including both, you use the closed brackets. So there's E. All right, next problem says the cost of 5 dinners plus 20% tip is $48. Write an equation represent the situation. So All right, so 5 dinners. They want us to use P for the price of dinner, so there's 5 dinners. Plus, we want a 20% tip, so that's going to be 0.2 times the cost of the 5 dinners, which was 5P. So there's 5 dinners plus 20% of the cost of the 5 dinners equals a total of 48. So you can enter that in. It probably will accept this, but you can simplify it as well. 0.2 times 5 is just 1. So that gives you 6P equals 48. So you could write P equals 8. That'd be a simplified equation, obviously. All right, next question wants us to determine if these are all equivalent. So first one, 3. Well, you can just multiply in any order, right? Multiplication is commutative. Order doesn't matter. So I'm going to do 3 times 4 times 2, which is 12 times 2, which is 24. So this turns into 24, and then x times x is x squared, and then y is left over. So it is the same. So you choose equivalent from the drop-down box there. Next one, this is 3x squared, and that's 4x, so they're not equivalent. Next one, 2c, and this is just 1c, so obviously they're not equivalent. You need 2c and 2c, obviously. Next one, x plus 3, x plus 4, this is x plus 3. This is, addition is commutative as well. These are switched, but it doesn't matter. 4 plus 2 is the same as 2 plus 4, or whatever x happens to be. So that's true, they're equivalent. Next one, 2xy times, and this one's not because 2 times 2 is 4, so it's 4xy. There's not a 4 here, so not equivalent. Next one, these are equivalent. Order doesn't matter when you're adding, again, addition's commutative, so you're adding 5 plus a negative x, basically, which you can switch and make it negative x plus 5 if you want. So those are equivalent. Okay, next problem says if x times y times z is 22, then what is this value? So basically we just need to get x, y, z out of this. So just multiply through. First of all, these 4's cancel. One at the top, one at the bottom. We have x times y times z, obviously. Order doesn't matter, so I'm just going to write x times y times z right in front, and then we have a 2. We just have 2 times that quantity that they gave us, so our answer would be 44. All right, now, questions like these seem really weird, but I like them because what they're asking you to do is simplify this and give the coefficient in front as n, right here, and then give what a is, what b is, and what c is. I'm sorry, the exponent, so r, s, and t. So basically just simplify this and then give what those things are. So to simplify, the numbers go out front, so we have 2 to the negative 2 power. Now, I'm going to simplify this, so I'm going to write 4b squared c squared to the 6th power all over, and I'm going to move this negative exponent to the bottom because then it becomes positive. So 2b negative 1 a to the negative 1 squared. Okay. Now I'm going to make these positive as well by moving those to the bottom, so I'm going to make this 2 over b, and I'm going to make this 1 over a, just because I like to get rid of those negative exponents. Now, to simplify from here, I'm going to do the numerator 4 to the 6th power, which is 4,096. And I have b, 2 to the 6th power would be 12. You multiply like that, so it's 2 times 6, which is 12. And then c to the 12th power all over. In the numerator, we have 2 squared is 4. B squared would be b squared times 1 over a squared. I'm going to simplify this as, I'll put the a squared right here, because order doesn't matter when you're multiplying. And then instead of dividing by a fraction, I'm going to multiply by the reciprocal. So instead of divide, I'm going to multiply by a squared, b squared over 4. Right, instead of dividing by a fraction, I can multiply by the reciprocal. So then the 4,096 divided by 4 gives us 1,024. And then I have a squared. B to the 12th times b squared. When you multiply like bases, you add the exponents. So 12 plus 2 is 4, so it'll be 14, sorry, b to the 14. And then c to the 12th. So that's what I'm looking at, which means my leading coefficient is 1,024. The exponent on a is 2, the exponent on b is 14, and the exponent on c is 12. This is a similar type of problem where basically it's asking you to simplify this, give the coefficient out front, and then give the exponent. So let's simplify this. X to the 6th times 2 to the 6th, which is 64. Yeah. X to the 6th times 64 times x to the 6th. I'll simplify that numerator real quick. It's 64x to the 12th. When you multiply like bases, you add the exponents. So So these can be added together. Multiplication, the order doesn't matter. So I just multiply this times this. Divided by x to the fourth. Now, when you divide like bases, you subtract the exponents. So it's 64 x to the eighth. So c is 64 and e is 8. All right. So properties of exponents, real quick. X squared raised to the third power, you multiply. So this is x to the sixth. So it's not equal. Multiply again, that's x to the sixth, so that is equal. When you multiply like bases, you add the exponents, so that is x to the fifth, and this is not equal. Okay, this one says the square root of x squared equals x. Well, you can always try this with numbers. You know, try like -2. -2 squared right here is 4, and the square root of 4 is 2. So that'd be 2 on the left side, if you did that, if you entered in -2. And on the right side, it'd be -2. So that's not equal. So if you enter in -2 here, you get 2, and if you enter in -2 here, you get -2. Those two things aren't equal, so that's not true. You can see the problem here. When you take the square root of something, you have plus or minus. You have to have plus or minus because of the fact that, you know, when you square something, the plus or minus goes away. So the best way I can describe that is this. When you have an equation like this, there's two answers. You could stick in -4 and get 16, but you could also stick in 4 and get 16. So because of that, you have to do the plus or minus to get both of those answers when you take the square root of something. So the square root of 16 is plus or minus 4 in math. Okay, next one. This one does work. You can try the -2 in this case, and you're going to get +2 on both sides. So this one does work. This is just another simplification problem. Once again, multiply through. So 6 squared is 36. Y squared raised to the second power is y to the fourth. Times 2 times, whoops, I'm sorry. 2 to the -1 is 1/2. This would be y to the -3, or 1 over y cubed. All right, so we're going to simplify this. 3 of these y's cancel with 3 of these, leaving 1 left. 2 goes into 36 18 times. So we have 18 y. So A would be 18, and B would be 1, because it's just y to the first power. All right, this problem wants us to find x, so we're solving this equation. Let's use our properties of exponents again. 2 to the third divided by 2 to the x. When you have like bases, you subtract, so it's going to be 2 to the 3 minus x equals 2 to the 7th. Now we can just use this one-to-one property. Our book calls it the one-to-one property, where we can compare the exponents. So we have 3 minus x must be equal to 7, if this equation holds true. So subtract 3, and you get -x equals 4, so x equals -4. Next one, same thing. Multiply like bases, you add the exponents. In this case, we have 2 to the x plus 3 equals 2 to the 7th, and then you compare 1 to 1 again. X plus 3 equals 7, so x has to be 4. This one's a little tougher because of the fractions, but it's the same thing. When you multiply like bases, you add the fractions, so that's going to be x to the 5 over 5, which is just 1, equals x to the z, so z equals 1. And then in the next one, when you raise an exponent to an exponent, you multiply. So you have x to the 3/5 times 2/5, which is 6 over 25, equals x to the z. So z in this case equals 6 over 25.